Hey everyone, I'm Jenny. In this series of videos, we're going to do a Q&A on streaming data. The leaders of Estuary have been hard at work attending many podcasts around the data engineering community, sharing their valuable knowledge. You may not have caught all of the podcasts, so we're going to do a YouTube series taking the best out of these podcasts and presenting the knowledge to you in a Q&A format. If you have any questions about streaming, feel free to leave a comment and we'll try to get to it in future videos in this series. In this first video, we're going to have Phil, our VP of Engineering, answer what is batch processing and in what ways is streaming different from batch. Let's get right into it.
I think if you talk about maybe some sort of formal definition of batch processing, which is probably pretty fraught, and you might get a bunch of people correcting me here, but really the basic thing is that in a batch process, you have a source for your data and a destination. And that is true of any data processing task that we do. And with a batch job, the source needs to accumulate data over time, for example. So say you have an operational database, and just for example, this is maybe a web app where you have a users table. And as users sign up for your application, we add entries to there. And the whole idea of a batch job is that web app is accumulating those users over time. So you have access to the both historical users who have signed up and maybe a user who signed up just a few milliseconds before your job runs. And those are all available to you in that table. And a good example, or illustrative example of a batch job is that you're going to take all of the data from that source. You might do some transformation along the way, but you're going to copy then all of it to the destination. And I think that's a good baseline place to start when you're talking about a batch job. In practice, that tends to not really work very well, especially as the users table grows, right? So if we're talking about a very small web app with a couple dozen users and maybe you get a few signups per week, that's great. The naive thing of just saying, take all the data from the source and copy it all to the destination can be totally fine. Obviously, where that stops working well is when you have a great number of entries in that table or a great number of updates to it over time. And that's where it starts to become very costly, right? I think a lot of people, where they start to become curious about streaming, is they say, okay, this is becoming very costly and it's causing us to run our jobs less frequently, right? So now we're spending more money and we're really delivering less value when we're maybe running our job weekly now because it's really expensive and it takes 2 hours or what have you. Streaming is oftentimes considered an answer for that. And that's one sort of entry point into the streaming ecosystem. Of course, people will be quick to point out, though, that naive approach to batch processing is not what a lot of people do. And a lot of people use batch tools, even at scale, and they use them effectively and they manage to keep their costs within reason. There's trade-offs there. And just like anything else in computers engineering, there's always trade-offs. At a high level, I would say that it's really to break down the problem. As I look at it, as the breakdown would be in really two main places. One is, if I want to make this cheaper, then I really want to be able to incrementally identify new data that I want to act on. So here's our naive batch job. Just a very simple users table. We copy the whole thing. Of course, in reality, this simple batch job is really many batch jobs, right? You're going to have additional users that sign up over time, and you want to get those all, say, to your data warehouse or whatever the destination is for you. So one aspect of this is now, okay, so we've had a few users added to our how can we make it so that we don't have to recopy all of the historical data, and we really just want to sync the new data? And this is really this is a good illustration of why I like to talk about this in terms of incremental versus non-incremental processing.
Yeah.
I think if we're just going back to the basic question of defining batch versus streaming, I think when we talk about streaming, there's really two aspects to it. One is that it's incremental. And that, I think, is honestly the more important factor to most people.
Yeah.
That's where you get your cost savings and things like that. The other is that it tends to be real time. Flow is a real-time streaming platform. You can do streaming that isn't real time. You can do batch that is incremental.
Next question. What are the challenges of incremental processing in batch jobs?
So back to incremental, and this is part of why where batch starts to get complicated is you want to do incremental processing like this. And one common strategy is you're going to do something like this, right? Where you add an updated at column to your database.
Yeah.
And now your batch job can do something like this SQL query over here, where you're really just looking for data that has been updated or modified since the last time you have synced it. This is super common, and it actually can work pretty well in a lot of scenarios. There are some trade-offs though. And probably the biggest, most obvious thing is that you have to go add this updated at column to your database everywhere. And every source that you want to treat incrementally has to have some sort of capability to do this. You've got some considerations there, like in this example, we're talking about a web app. Maybe you just have a Postgres database. Probably pretty easy to add an updated at column for most of those things. If you want to be fancy, you could even have a trigger that updates it automatically. Your application maybe doesn't have to be quite as impacted. Conceptually, you're still on the hook to really put this complexity into your source systems, right? So it's not part of your data pipelines anymore. It's also in your source systems. Some of the other trade-offs here are, okay, when we talk about orchestrating these jobs, when we're orchestrating these batch jobs, that last sync time is state. And it's state that we have to really manage now in order for our jobs to run correctly, right? If we're going back here, we have a job that's going to run and just get the users from last sync time. What is that last sync time? That's one bit. The other bit is that not every application is capable of being instrumented in this way, right? There are certain sources that just, it's going to be really hard to do something like this. A good example might be something like clickstream data or, webhooks that are coming in. You may not have the ability to do this for everything. Yeah. And that's where streaming becomes really nice, because you don't have to have any kind of special process, right? So again, going back to that really basic definition of batch, right? It's when your source is accumulating the data and then you have a job that just reads it all. The source can't always accumulate that data. And sometimes we end up doing things that less than ideal, right? Like we might have to build in accumulation of that into our pipeline somehow. So it can get pretty messy. The orchestration of that is again, that's also a kind of an additional dimension to the problem. And in particular, the orchestration to me is a problem because when that orchestration, when you have all these batch jobs, they're actually stateful because they need at a bare minimum, like a last sync time or something like that. But you're never really looking at these things in isolation, right? So this is the kind of the danger in maybe overly simple examples. right? If we're looking at one batch job that's just copying data from one source to one destination, that problem of state, it's just a last sync time. Come on, how hard is that? In reality, for most of us, we're not just dealing with one source and one destination. We're dealing with a lot of times a great many sources and oftentimes more than one destination as well. To muddy the waters even farther, in reality, there's also this desire to say, okay, we actually want to do some aggregation before we even land the data, right? This is a common thing when we're talking about business decisions that rely on large aggregates of data. One thing that you could do is to say, you know what, we're just going to copy all the data into the data warehouse and let everything else happen there. And it's a common thing that's really pushed by ELT vendors. Yeah. And I think that it is something that can work for some people. It also has a lot of downsides, right? So there's a lot of reasons why it can be better to really do some aggregation before landing that data in your, whatever that kind of final destination is for you.
Yep.
And that adds in a lot more complexity, right? Because now you have this kind of graph of jobs that all depend on each other. So you've got dependencies between jobs. You've got jobs that sometimes even depend on the data from your data warehouse so that they can do things incrementally and still produce meaningful aggregates. And in all of this, your failure scenarios are sometimes quite complicated, right? So what is your last sync time when just one of these jobs has failed? These are things that have answers, and they're answers that are always just, they tend to be a little bit unsatisfying and come with other trade-offs. For example, you can do it incrementally as long as you have an updated column, but for systems that don't have an updated column, you've got to do something else.
Yeah.
Then you've got to figure out how to marry those two different systems together and make them work correctly. The way I see it, streaming, at least conceptually, can simplify. So a big difference with a streaming system, just right out of the gate, is that your jobs don't run sequentially many times over time. It's conceptually a long running thing. Right? I might have a stateful job here that is really, it's running continuously and continuously reading data from the source. And so that can be nice in terms of it's both incremental in that it's maintaining its own state and it is only copying over things that have been updated since the last time that it has looked. But it's also then low latency, right? It's because it's essentially doing the same thing. You might as well keep it running if you have a system that's updating very frequently. And so you're removing a dimension from this graph of jobs. And each of these jobs is able to read from the other until you get your final set of data products that you want to push out. And again, that pushing out can also be incremental. That's really what our focus has been on with Flow, is we're really not trying to reinvent the wheel when it comes to streaming. But what we are trying to do is take these existing paradigms that work for, basically, we're trying to take something that is in reality very complicated, which is managing each of these stateful jobs and taking care of all the other problems that kind of come along with them, and making it conceptually simple. In a very similar way that, say, something like Airflow has done for a batch process, where in an Airflow DAG, for example, if one of your jobs fails, then Airflow can know about it and do the right thing. It gives you some consistent best practices for error handling, monitoring the status, and things like that. And that's a lot of what we're trying to do with our platform, is really take this and make it similarly very simple, consistent, easy to work with.
I think
In our next Q&A video, we're going to have Johnny, the CTO and co-founder of Estuary, go over what are write-ahead logs and what are the gotchas you should know about. Stay tuned, and remember, if you have any questions you would like answered, feel free to drop it in the comments. See you next time.